Everybody, my name is Carl Andersson. I'm professor for pervasive and mobile computing at Luleå University of Technology. I have the pleasure to introduce our project Digital Urban Development, Campus Skellefteå, together with our partners Skellefteå Municipality, Skellefteå Kraft and ABB. Before I do that, I just want to mention a few words about our development areas, including making surrounding properties more energy efficient, changing consumption in surrounding buildings over time. Furthermore, we are providing energy storage to balance loads over time, and also we are designing new properties to match the existing energy profile. So by this short introduction, I want to hand over to our first speaker, which is Mrs. Sanna Oriano, representing Skellefteå Municipality. Please.
Thank you, Carl. Yes, I'm Sanna Oriano, and I'm a process manager at Skellefteå Municipality and for Arctic Center of Energy. And I would like to give you an insight about the new competence center that we are establishing in Skellefteå. And it has quite a close connection to the project Digital Urban Development, as Carl previously mentioned. And Arctic Center of Energy is an effort that is based on the fact that Skellefteå and northern Sweden have taken the lead for the European green transition due to our many beneficial assets. I think most of you probably know that Northvolt recently started producing the world's greenest batteries here at their gigafactory in Skellefteå. And this is not only an important step towards a new battery industry in Europe, it's also started a huge demand for workforce at all different levels and areas at the labor market in this region. At Northvolt alone, 5,000 skilled workers will be needed when the production is fully ramped up at Northvolt 1. And that is not enough. This establishment has also created a ripple effect. A new ecosystem of battery-related businesses are under establishment in this region, amongst a huge demand in other industries, all of them enabling the green transition. And of course, along with lots of needs of services, businesses, public services as teachers, nurses, you name it. And in total, we're talking about a 20% growth of inhabitants in Skellefteå the coming years and 14,000 new jobs in Skellefteå by 2030. And this has put Skellefteå in an historical and unique societal transformation. During the next coming 10 years, investments for around 100 billion Swedish crowns are planned here in Skellefteå, and that is in housing, infrastructures, and new businesses, as mentioned. Furthermore, we are determined to grow in a sustainable way, and that means that we're facing the challenge to reduce our carbon dioxide emissions at the same time as we grow in a fast speed. And we believe that the way to enable that is through electrification. That's crucial. And therefore, several actors have joined forces to create a new competence center in Skellefteå. The initiators behind these competence centers are Luleå University of Technology, Northvolt, Municipality of Skellefteå, Skellefteå Kraft and RISE. And the aim is to accelerate the electrification of society. And through this joint effort, we can take the advantage of the fact that we are in the lead when it comes to green transition in this region. And we have all of the conditions in place to create models for a fossil-free and electrified society and lead the way for others to follow our example. And but to be able to do so, we need more research, new knowledge, and new collaborations. Through Arctic Center of Energy, we create a new meeting place where we can invite world-leading actors within the electrification field and together build the abilities that are needed to make a change. Because one important part to make this transformation possible is to explore new types of ways for education. That's one very important focus area within Arctic Center of Energy. We need to find new ways on how to educate and quickly meet the high demand of new skills that the transition requires, and that is at all levels. And to make this effort possible, the municipality is building a brand new house at Campus Skellefteå. And this building has very high ambitions when it comes to sustainable construction. The house will be certified according to the highest certification levels for sustainable buildings that are accessible in Sweden. And the house will also become the heart for research, innovation, and collaboration to find new ways for electrified society. And one important part of this investment involves making Skellefteå as a city available as a test and demo arena for new solutions, not the least when it comes to new ways to manage energy systems in this house, but also in other buildings in Skellefteå. And through this digital urban development project that we are running together, it can make this possible. It give us the possibility to try out new management systems for this house, but also for Skellefteå in the future. So it's a very important milestone when we're pushing the boundaries on what is possible and creating a test bed at Campus Skellefteå, so we also can test and learn and share our knowledge with others. And I will hand over to Patrik to tell you more about the energy system.
My name is Patrik Sundberg, and I'm head of energy solutions at Skellefteå Kraft. Skellefteå Kraft is both an energy supplier and a strategic energy partner to the property owners in the campus area. In this project, I'm responsible for the system perspective. If something is good, it must be implemented, even if new business models are required. This project began with the need to increase the number of students within the e-game education program at campus area. This was difficult given that the availability of air conditioning and electricity was limited. There was simply a lack of power, but was it also a lack of energy? We did an energy analysis of the entire area and found that there are opportunities to make the existing property portfolio in the area more energy efficient, so that the energy will also be sufficient for the new needs. The question is whether we can move the energy in time and in space so that the efficiency can also cover the power needs. The next question is whether this can also be enough to supply the brand new ACE building. As I said, we started with an energy analysis that gave us information about energy use on a monthly basis. Smart energy meters are then installed that show instantaneous values. These values go into a digital twin where we simulate different scenarios in both energy efficiency and energy use. The twin is analyzed with artificial intelligence so that we can use so that we can see where energy efficiency is most beneficial and what amount of energy we need to be able to store to cover the upcoming power needs. We will also install locally produced energy, and with this model we can optimize the facility's size and location. Energy storage is a key to how we optimize the use of energy in the future, and with this technology we will be able to dimension the size of energy storage and provide support to those who want to invest in batteries in their properties. And with that, I leave the word over to the team at ABB. Linnea, it's your turn.
Yes, thank you so much, Patrick. So we are the team from ABB. Pleasure to see you all here today. My name is Linnea Eronen, and these are my co-workers Matteo and Mikael. And in this VINNOVA project, I have been working with the knowledge management. Matteo here is the technical lead, and Mikael is the project manager. Yes, so change slide. All right, so let's start off with some background about ABB and the business that we are working in. ABB is a global tech company that actually turns 140 years this year. So that's definitely worth celebrating. And we have a long tradition of being in the forefront of transformation. And we want to be a leading company in the transformation of the society and industry to achieve a more productive and sustainable future. And there are several interesting fields where we are working and where they're happening a lot of exciting development right now. And here we truly believe that electrification and digitalization is the key. In urban development, as we're talking about in this project, there is a large potential to involve the existing way we build city areas into new ways. So where the energy system today is a load in the system, but it is that a dynamic and flexible asset to the energy system as a whole instead. And in this way, we can transform buildings from being large emitters of greenhouse gases into sustainable assets, which enables the transformation to renewable energy sources.
And the main global challenge is to transit from a fossil fuel-based society towards a renewable technology-based. And as Patrick said before, this means implementing, among other things, energy efficiency and flexibility, which means using less energy and using it in a smarter way. And this perfectly comes together in the Skellefteå-Campus project. And as ABB, we were proud to participate in it as a technology provider, and together with VINNOVA to push towards digitalization and innovation. This means using artificial intelligence and analytical tools together with smart hardware, as I was mentioned before by Skellefteå Kraft, to simulate and control the building energy loads towards optimization of the energy curves. And as we can see here, in this slide is very complex when we tackle energy systems, and our scope in this project was also to build a co-creative knowledge in order to understand all together with our partners and with VINNOVA how a project like this can come together and also build an expertise that we can use in the future. And this has been used by us and by other partners in another VINNOVA financed project called Integrated Learning. We really think that knowledge is important, but shared knowledge is the real key to change and disrupt the status quo, and so to innovate. And once again, as one of the technology leaders in the world, as ABB, we are really proud to be part of this Skellefteå-Campus area project, which perfectly matches our values at ABB, where every day we live up to the curiosity and the courage to innovate. And now I leave the stage to Sami from LTU.
Thank you from Team ABB for giving me the opportunity to talk. So now to this project, the Digital Urban Development for Campus Skellefteå. So I will be talking about my contribution for making energy efficient campus Skellefteå. So I am Sami Kobir. I am a PhD student in the Computer Science Division of Luleå University of Technology in Skellefteå campus. And concerning this project, actually, as my previous speakers also talked, that the main objective is to make the campus Skellefteå the energy efficient, the energy consumption, we have to make it as efficient as possible so that we can supply whenever it is needed, actually, kind of as I have mentioned in my first point, that demand flexibility based energy consumption prediction. So it's like on demand energy supply. Whenever we have some peak time, we supply energy to that very area during the peak time, and during off peak time we preserve the energy, and for certain disruption, for seasonal variation, we have to act accordingly. We have to accommodate the seasonal variation, weekly pattern, daily pattern, and so on. So instead of continuously supplying energy, we focus on on-demand flexibility-based energy supply. And for this purpose, we need actually prediction. So the artificial intelligence, AI-based energy consumption prediction, this is an objective in this project. So there will be the digital twin, which will supply energy to the area where it is needed. But for the digital twin to predict actually when I need energy supply in the peak time or what is the off peak time, that part for we need the artificial intelligence. And to make the predictive output transparent, we need the explainable artificial intelligence, XAI, to make the predictive output transparent, so that the rationale, the reason behind a predictive output is clearly communicated to the stakeholder in an intelligible way, so that it is clearly understandable to a human user in non-technical and simple language, of course. And with this, we build relationship of trust between stakeholder and the digital twin. So that whenever the reason is clear, then basically the decision of a machine will be much more trustworthy to the stakeholder. And one of the main challenges of this project is the accuracy versus explainability trade-off. This is a key research challenge of this research. So we have traditional neural network or machine learning models which have high accuracy, but they are mathematically very complex. So if we reduce the complexity, we need to compromise with the transparency or explainability. So how can I have an algorithm where we have both high accuracy and high explainability? That is the main research question, that where is the accuracy versus explainability balance, the trade-off between accuracy versus explainability? What are the metrics to determine both accuracy and explainability are well addressed in a machine learning or deep learning algorithm? That is the main research challenge. And with this, I wrap up my part. So you can scan this QR code to know more about the project details. And then I pass my floor to my next speaker, Adnin, who will talk about the digital twin in this project. Thank you.
So yeah, in this urban development project, my contribution will be creating the digital twin of the electrical network of Skellefteå campus. So I will explain why we actually need the digital twin in this project. So digital twin in the power system, the requirement of it is that in current power system, we have different network components, like we have power supply from solar panel, wind energy, and we have also new loads like electrical vehicles. And those new component we have in the power system, it comes with a lot of necessity of operational and planning management also, and also there comes with lot of power electronic devices that comes with a lot of voltage disruptions, harmonic problems, and like supraharmonics or voltage dips. So to analyze those problems for future prediction, we need to know how the network actually performs in such scenarios. So to create the digital twin, we have a framework like how we can establish the digital twin. Like first we need to model our twin according to the network's signal line diagram, and after creating the twin, I will work through the twin with an analysis considering different scenarios, like we will change the load, we'll do the network modification, and also we get the data to understand how the consumption actually have it at different time level throughout the day. And we will continuously analyze the power quality at the different level of the network, so we can understand where is there any problem in the network of power quality, or we have any increased demand of load, so that we need to have curtailments. So yeah, that's from me, and I give my floor to Annika.
Thank you, admin. I'm Annika Svensson, and I work together with Carl at the Center for Distance Spanning Technology at Luleå University of Technology. And I would like to welcome all of the speakers up on this virtual stage for a short panel discussion. Thank you so much for joining me. This was so interesting to listen to you guys' presentation. And I think I will start with a couple of questions to each of you, and then some joint questions towards the end. Sanna, it was so interesting to listen to everything that is going on in Skellefteå, and I bet there is a lot of construction going on now. And looking at what we are doing in the Digital Urban Development Project, what key learnings do you expect as a municipality to take forward from that into the ongoing and the future projects that you have in Skellefteå?
Mm-hmm. Thank you, Annika. Yes, as I mentioned earlier on, we are growing. We're basically planning for a whole new city. So, of course, it is challenging, since we're also very committed to making this transformation in a sustainable way. And I mean, it's one example is the housing. You mentioned one of the many constructions. We're planning for around 1,000 homes to be built yearly the upcoming years. Of course, the whole mobility system also affects. We need to find new innovative ways of transporting both people and materials in a fast-growing city. So there's a lot of constructions ongoing. And it's very important for us to work closely and with research and make this type of collaboration like we do in this project to really be in the forefront and learn from each project. I think a lot of partners in this project also were involved when we constructed the culture house Sara, to mention one example on pushing limits on what's possible to build in a sustainable way. And we all learned very much from that project, and learnings that we can take with us to this ACE house that we're building, for example. So yeah, collaboration is a key, and I think we can have from this project, but also this need we have to, we really want to share with others our knowledge, and I think by this project we also have the possibility to visualize a lot of learnings and make it accessible for others to follow our lead.
Mm. Yeah, interesting. Sharing, I guess, is a big part of this project, as in all of the VINNOVA finance projects. So I know there is a team who has a lot to share with us from ABB. Could you give us a couple of examples where ABB has been working with similar energy management solutions before?
Yeah, so one was just mentioned, the Sara Kulturhus. That was a commercial project where so the culture house in Skellefteå is a state-of-the-art building. It's like a carbon negative over the life cycle. So that's super interesting, and it's open for visitors. So there you can go up and check out our really cool energy system that we put in. And basically, it allows Skellefteå Kraft and the local utility company to use the building smarter, to use the building as a positive asset to the city to reduce carbon emissions by using artificial intelligence and optimization tools. It's super cool. We at ABB right now, we are in Västerås, and here we have are just ending now another innovation project where we are doing a digital twin over a city area that is not yet built in the planning phase. And here we have built a tool where you can simulate different buildings and see how they interact with each other, and how you can identify how they can be constructed differently to help the city developers create sustainable cities. What we're doing in this project in the campus area is unique in that way, that is existing buildings already. So, and this is super important. We want to do the same thing. We want to analyze with sophisticated tools how we can reduce energy consumption or shift loads in a way so that it's more sustainable and possible to expand the city. And this is very important to look at, like existing buildings, because most of the buildings, maybe 98% of all the buildings that are here now, will also be existing 2050 when we should have reached our sustainability targets.
Yeah, it sounds like you have a lot of knowledge to bring with you, and I bet that the project you mentioned from Västerås will be feeding into this project that you are doing now together with us. But looking at all the solutions you've done before, like Sara Kulturhus and what you're doing in Västerås, in what way do you expect, if you visualize the solution that you do for this project, to be different from that?
It's the same idea, only on city level instead. Mm-hmm. So that all the buildings are harmonized, or the energy system is, they are talking to each other, basically, the buildings, right? So not, and this is a huge complex situation now when we are electrifying and the electromobility is coming into play, when everybody, just an example, everybody wants to charge at 5 o'clock. That's not going to be possible in the near future. So how do we solve that? Then we need some sort of a optimization tool where you can shift loads and manage this. And to do it correct in a smart manner, then you need artificial intelligence. You need to do forecasting models. And then, as Patrick was mentioned also, this requires all the participants to shift a little bit their business model. And this kind of knowledge, complete knowledge base, this has to be developed. So we need to learn from each other in different projects and build consortiums like this, where we with different stakeholders involved to learn from each other how to do it.
Interesting. Thank you, Mick. That was great. Patrick, you know, this shifting energy loads between different parts of a city or a district, I guess that is what you guys at Skellefteå Kraft are doing all the time. Do you have any comments as to what Mikael was just telling us about?
Not really. I agree fully. I used to say that we started with one small little house. Then the next step was to take it to a really big house, this Sara Culture House. Now we are testing the technique and the business models on several houses with different owners. And the next step, we are taking it to smaller cities.
Oh.
So it's like the evolution of the energy system.
So it's like a big laboratory, only in the full scale, right?
Yeah, but the difference is that in a laboratory, you do it just for test. Exactly. We are doing it like the normal in our daily operations. We take the good with this to next project. We don't write a report and stop there.
I guess everyone in Skellefteå and the surroundings are pretty happy about you taking this serious as a real project as well, and doing it for real and not just as a laboratory. That's true. I'm just thinking about, I know that sustainability is really important for Skellefteå Kraft. If you look at the sustainability development goals, what would you say would be the main contribution to them from this project?
Well, we believe that this project can demonstrate the benefits of collaborating in an energy system. Usually, energy consumers see any efficiency improvement as the value of the kilowatt hour. But done right, you can win so much more. And with increased knowledge about the energy storage and the energy management, we will make it easier to do right. Then that's one of our goals in this type of projects.
Sounds really good. And to do things right and to facilitate things and facilitate for the future, I think that is also what the digital twin is all about, admin, isn't it?
Yeah.
Yeah. In what way do you think that the digital twin in this project can facilitate future construction in the campus area, for example?
Yeah, if through the digital twin, as I also said in my presentation, that through the digital twin, I will going to analyze and understand how the consumption behavior is going through the Skellefteå campus. So that will help us in distribution network planning, operation management, and control. Also, through the digital twin, we will be able to analyze the power quality, so we can provide a reliable power supply throughout the campus that will provide in future will provide us an efficient energy management system. So it will help us in future to have the load consumption, demand consumption settings, and so we can have supply all the demand within the limited resource and limited energy. So that's how I think the digital twin will help us in future construction of campus.
Yeah, thank you, admin. The limited resources is really a thing for that we need to, the constraints that we need to care for, all of us. I was thinking about your presentation, Sami. How do you think that AI can be used for tuning and developing the energy management system once the ACE building is actually there and has been built?
Thank you for giving me the opportunity. AI can be used, as my colleagues from ABB also told, that the forecasting model they need, because you have the digital twin in place, then you have to predict actually at what time you need in the peak time, what will be your optimum energy consumption, when do you need energy at the highest level, when do you need typically low level. There will be some such consumption behavior pattern, and there can be some seasonal variation, so many issues. So that means you need more data actually. The more data you have, the more consumption data, people's energy consumption data, people's behavioral data you have, the more better you will be able to train your artificial intelligence model. So that is one aspect, the availability of data that we have to ensure. And another issue is the transparency. So if AI, we view AI as a black box model, we give it as input and it makes some sorts of reasoning in a non-transparent manner, in an opaque model, and then it gives you a certain output. Then there is no way to understand whether this output is really the correct output, or it is biased, or it's erroneous, or it is really domain knowledge compliant. So you don't have any opportunity to understand whether this output is really the actual output, the correct output, or it's not a biased one or something like this. Because if your training data are biased, then it is highly likely that your AI will give you biased output as well. So that's why we are focusing on transparency issue, the explainability of artificial intelligence, that in addition to giving you the output that right now you need very high energy demand right now. So you have to supply very high energy, very high level of energy to that area of campus Skellefteå. In addition to that part, the digital twin also has to give you the why I am saying you that area of campus Skellefteå needs very high energy demand right now. You need to supply it more. Why? Maybe because there is a social event today, or there is a laboratory exam going on where they need some high computing facility for graphical processing unit for research purpose they need. So you need to supply more energy, something like this. And so that is the point. And I just want to talk about another issue, the question you asked, Annika, that the SDG, the Sustainable Development Goals, which SDG goals actually this project contributes to. For me, I should say at least 3 goals this project contributes to. If I talk about the first one, the sustainable goal number 11, the sustainable cities and communities. Okay, so of course this project contributes to a sustainable city, to make Skellefteå a sustainable city. Then we have SDG goal number 12, the responsible consumption and production. So if we can understand people's consumption behavior and make them aware to minimize their consumption or minimize the energy wastage and so on, that will make people consume resources more responsibly. And another issue is the SDG 13, to some extent, I should say, the climate change issue. I mean, the more we rely on renewable energy or fossil fuel-free energy, the more we can able to tackle the climate change. Though it's not directly relevant, but to some extent, as it concerns the energy production, the energy consumption, so we need to focus more on renewable energy sources rather than the fossil fuel sources. That is also an issue to consider. Yeah, thank you.
Thank you so much, Sami. I think we are running a bit short of time. So even though there were more questions for our panelists, I think I would like to conclude and thank you for allowing me to manage the panel today. And I would like to welcome Carl back on the stage to wrap things up.
So I'd like to thank all my colleagues. It's an amazing team we have put together. I hope you enjoyed the presentations and the panel at the end. Before we wrap up, I want to acknowledge the main financier of this project. It's our innovation agency, VINNOVA. Our project will go on until July 2025, so there is plenty of time to interact with us. So if you have any ideas or want to talk to us, we are available on the web at digitalstadsutveckling.se. Stay tuned at our website for updates and feel free to contact us at any time. By those words, I want to thank you for watching and hope to see you soon again.